Hello everyone, my name is Hamid. I'm a researcher at Brown University. In that role, I'm working on the software development, specifically software that we developed for the WECMA project. So far, we released 3 versions of this software named FabSim. Since 2 or 3 months ago, we decided to move and prepare a containerization container image for this project. So I'm responsible for this one, and during the past 2 months, I have some experience with this container. So in this presentation, I'm going to share with you with some problems that I faced, and mostly focus on how we can optimize the image in terms of the size and the build time, specifically because it's really important when you have a CD, CI process in your system. So let's go past this here. So the first thing is that we all know that the container is the standard way to package all application and all dependency. Our goal is that build an image, ship it, and that image can be run at any system. Okay, so basically we can install apps on an image and run it at any system that we wanted. When we compare it with VM, so container has a more portability, gigabytes vs the megabytes that we have it, has a better performance in terms of the runtime. It's a better management cost, and more great advantage is that DevOps and microservices. That's we are focused on these 2 parts today. So first of all, Docker. We all know Docker is open source platform for developing, shipping, and running application. The general workflow of the Docker is that we generate it, build an image, push it for other people can download it and use it. So I think that the most important thing in this particular workflow is the image size. How much is that image, and specifically how much takes in the continuous development at each stage you build a new image So let's move. I'm sure that most of you are familiar with the syntax of the Dockerfile. So let's look at how we can optimize the Dockerfile. As we all know, Docker uses the layer. So basically, we have a basic layer as a base image, and each command that we run tagged as a layer. So the layer content is really matter, and the more important is also the order. Is the best way to optimize your container is that first we put the less frequent update layer at the top. Why? Because as we know, Docker uses a caching system. At each level, when you want to, at each step, when you want to build it, if the one layer is not touched, can be reused from the cache. Okay. The second one is the order rule. It's better that we put the static instruction in the higher level. The static instruction, but not limited to the command, entry point, and work directory. If it's possible, sometimes it's not possible. It's completely based on your application. Maybe sometimes during the your Docker file, you need to download some source code, change the work directory. So it's completely depends on your application. It's better also to place the dynamic instruction in the lower order, because it's become in the dynamic layer. So every time it's changed, it has a lower number of the children, so the build time will be decreased. And also, it would be better that we place the run instruction before add and copy, if it's possible. it depends. As I mentioned, it depends. Maybe sometimes you want to copy from your drive to the, for instance, the Docker image. You put your configuration, the software that you want to install. So in that case, you have to put the run after the add or copy. But always keep the dynamic ones like the argument environment, other things at the lowest level. Okay. The most important one is better when and where is possible, combine as many run you can, okay? Because by not combining, every time that run is executed, it's marked and flagged as a layer. So it's maybe it's not effect on the building time, but on the image size, maybe it's effect. And also, it's always recommended that use the, for instance, for the apt-get install, use not install recommend. Why? Because we all know when we install some applications, a lot of unnecessary library for the future usage will be added. So it's better that we remove this one to decrease the image size. And also, if after installing the application, try to clear the application list. The base image is the most important one. A small base image is better, but if we don't fill it again with a useful, useless software. For instance, in this simple example, you can see by changing the base image, you have a really good decrease in the image. But again, it completely depends on your application. Maybe you decide to use the smallest image, but after that, you have to install it during the process. You have to install lots of the library. So first check it to see which application, which approach give you the better and the lowest image. And the ignore file. This is a really nice feature of the Docker, but most people are not using it. Okay, it's similar to the GitHub ignore. Okay, generally when you use in most projects, when you use the add or copy, maybe you push all your Git repository or secret files like AWS, N1, private key into the application, and it's happened. It's happened once. A commercial approach, a commercial software provide a Docker file, and someone can touch and find the source code. After, I think, 5 minutes, they fix this problem, but it's better that you list it. Before that, you prepare and push your Docker file, list all unnecessary files, and mark it in the Docker ignore file. Okay, let's move. For instance, look at to this sample in the GitHub. Okay, as you can see, by running a simple, really simple optimization rules, they can reduce the image size from gigabytes to megabytes. And the most important part is the building time, from 2 hours and 40 minutes to 1 hour, around the 2 hours. So that's a really important one when you have a continuous development. So let's see how we work with the Docker in the CI/CD. Continuous integration, continuous delivery. In our cases, in our software, we use the Terravis. There is a lot of other approaches and you can use it. But let's first talk about the problem that we face. Okay. The first thing is that the simplest way, Docker Hub provides you an automated build. So you can directly connect your GitHub to the Docker Hub. Define it, and Docker, if after each push, build the image. But this one has a serious problem. Not serious, it has some drawback. Running test, the automated build doesn't support the running test. we all work on the some projects. Different team works on the same projects. Okay, during the delivery. Okay, we need if someone push the code running to some tests, but Docker, but automated build of the Docker Hub doesn't support this feature. And the another important and annoying things, I think, is that if you have a multiple version from your application, for instance, look at to this official MySQL server GitHub. They have a several version. Okay, for each version, because they directly connected to the Docker Hub, they provide a specific and individual folders, and then put a Docker file for each version, then to connect it to the Docker Hub. So we can use the CI/CD tools. In our case, we use the Travis, but Travis has one problem. It fails to sync the README. Also, Docker CLI, when we use the Docker command inside the Travis, cannot update the description on the Docker Hub. Or the another example is here. If you look at to the two version of this application, the only difference between two versions is just only one single line. So, but they provide two separate files in two different folders because they directly connected to the Docker Hub. The workflow that we are using in this project is that the developer push the code, the GitHub trigger the Travis. In the Travis, we use the pipeline stage. So to support the running test. And if every stage is fine from the Travis, we push it to the Docker Hub. Let me to okay. This is a last version of the software that we released. In this version, we use a simple stage. So currently we have two stages. We have two stages. At the first stage, we test it. At the second stage, we push it in the Docker Hub. As you realize that here, the Docker Hub for our software for now, it just has a one version. Okay. During the past 2 weeks, I work on this because I'm responsible for this containerization functionality. Okay. So to fix this problem, the solution is that instead of this to having the single Docker file, okay, you just hack and write some simple bash scripts. Okay, and then from this Docker Hub, try to check the version that you want with this solution. For instance, so far we have 3 versions. So we can tag each individual versions. And also in the next release, we have the development versions. The development version, it means that's the last successful version of our application, not release. So basically, when we want someone else wants to use our application, has the opportunity use the last stable or development version. Okay. Right now is not pushed because I had some problem with the Travis when we push the key authentication to the Docker Hub. In here is simple because we use the encrypt and decrypt. Okay, but when we move to the scripts, there is some problems. I'm working on it, and in the next release, I think that problem will be solved. So after that, easily we can have a different tag for each version and development version without only single Docker file. So we don't need to follow these steps and generate an individual folder for each Dockerfile. That I think that's not useful. Also, there is a Singularity version of the our application from the FabSims. Okay, so we in that Singularity version, we provide a complete document, so you can download it, follow the application. It gives you exact instruction how you install the FabSim in your systems, and how you can run it, how you can, this script automatically add the all instruction that you need to execute to your bash RC files. So after that, the second one that you run and start up your machine, so you are, you will be easily use the FabSim without any problems and without requiring install any additional software, just using the Singularity image. And for sure, for the next release, currently we are in this project. We are working with some super company from the Poznan. They develop an application for the managing the jobs in the grid. Currently, the FabSim support the submitting the jobs monitoring. In the next version, I'm working on that to integrate that pilot job manager to run and execute assemblance and the workflow as a pilot jobs inside of the any supercomputers that support the SLARMs. Okay, and maybe in the next version we have this type of the functionality, at least for the static mode, not for the dynamic workflows. Okay, just that.